questions from homeworks? To this point, you guys have been assigned the worksheets 1 and 2, as well as like 11 through 14 and 17 to 18 or something like that. I forget what it was last time. I think that was right. Let's look real quick. 11 to 14, 17 to 18, yeah. Do we have any questions on any of those worksheets 1 or 2, or 11 through 14, 17, and 18? Nick? Worksheet 2, number 10. Okie dokie. So the first thing that I would do is try to decide whether this problem is a calculator problem or a unit circle problem. So to do that, all I'm going to be doing is looking at the number right here. If that's not a unit circle coordinate, it's a calculator problem, right? So your unit circle coordinates are like 0, 1/2, square root of 2 over 2, square root of 3 over 2, root 3 over 3, 1, and then the negatives of all those things. So clearly a calculator problem, right? Okay. So to start a calculator problem, I'm going to start by drawing my picture. So I'm going to draw out my XY axis. And I'm going to look at this piece right here. So theta is my answer that I'm looking for. Theta needs to be between two negative numbers, right? Everybody agree with that? That tells me that my answer for theta is negative. So I'm going to start by figuring out what two quadrants are covered from negative 7 pi over 2 to negative 5 pi over 2. And since those are negative values, I know I'm going to be going clockwise as I do my counting. Everybody's good? Now I'm going to count each quadrant one at a time. Each quadrant is 90 degrees, or in the if we're working in radians, that's the same thing as pi over 2, or 1/2 a pi. So we're going clockwise, so that's 1/2 pi, that's 2 halves, that's 3 halves, that's 4 halves, that's 5 halves, that's 6 halves, and that's 7 halves. Is everybody okay with that? So we ran into negative 5 pi over 2, and we're still going clockwise. We end at negative 7 pi over 2. So we're covering quadrants 2 and 3. So far, so good. Nick, are you happy so far? Yeah. So, okay. So we're starting here at like 0, negative 1/2, negative 1 pi, negative 3.5 pies, negative 2 pies. Negative 2.5 starts here. Negative 3 pi, negative 3.5 ends there. So as we kind of like circle around, that's... I said negative 2.5, negative 3, negative 3.5. Right? So I'm just looking at those. No? Do we need to start over? Try it again?
Are we looking at the 7 pi over 2 and the negative 5 pi over 2? Is that what we're looking at?
Yeah. Because we need something that's in between those two. Right? Does that feel okay? Nick, are you okay? Okay. The second piece that we look at is now we look at this part. So theta equals sine inverse of negative 0.44 is the same thing as saying sine theta equals negative 0.44. But what I really care about is that sine theta is negative. So if I use my all silly turtles crawl, I know that those letters are telling me which trig functions are positive in that quadrant. So A is all of them are positive. Well, so sine can't be negative there. S is sine is positive. Well, sine can't be negative there. T is tangent is positive. So sine and cosine are negative. So that's one that I might want. C says cosine is positive. So sine and tangent are negative. So that could be one that I want. So far, so good?
So if it's a negative 1 by the sine, that makes sine negative?
No, because it's equal, sine theta is equal to a negative number.
Oh, I didn't like the number. Okay, yeah.
Okay. So which quadrant is the terminal side of my of theta going to lie in then? Quadrant 3. So let's draw our picture. So there's my initial side. We're going to go we're going to go clockwise. So negative 1/2 of pi, negative 1 pi, negative 1.5, negative 2, negative 2.5, and then my answer's somewhere over here.
So we know it's in the bottom left it's everything that we
Yes. Yeah, because it satisfies both the equation and the interval. So far, so good. Next, I'm going to draw in my angle theta. Or I'm sorry, my angle alpha. The alpha is always between the terminal side of theta. So that's this. And the x-axis. So there's my alpha. To compute alpha, I always do the inverse of the absolute value. So far, so good. Now, to finish this off, to write my equation for theta, I'm going to use the picture that I've drawn. That's the entire purpose of drawing the picture, is so I know how to write the equation. So the number that goes here is going to be the label on the x-axis that makes up alpha. So alpha is here, so that number should be negative 3 pi. That's good. Always the x. Yes. Oh, we're not done writing the equation for theta yet, but that's the first part, is always going to be the part of the x-axis that makes up alpha. And then to decide whether we're going to be adding and subtracting alpha, we're going to look at, you're welcome. Ella, this is yours. We're going to look at the where did my thing go? We're going to look at the axis that I cross right before I get to the terminal side. So in this case, that was the y-axis, right? Everybody see that? So the rule here goes, if theta is positive and then we cross the x, we're going to be adding. If theta is positive, and then we cross the y, it's subtracting. If theta is negative, it's just going to be the reverse. Everybody's okay? So we have a negative theta, and we cross the y, so this should be adding. Is everybody all right there? And then always alpha to finish. So the picture is going to tell me, what do I start with? Should I add or subtract? But it always ends with alpha. Sine inverse of absolute value 0.44. Yes. So to put this into my calculator, I'm going to first make sure that I'm in radian mode. So I'm going to do that to start. Then negative 3 pi plus, and then sine inverse absolute value of negative 0.44. But I'm just going to do the absolute value in my head because it's like a lot of menus to step through to get the absolute value on the calculator. So I get negative 0.8 or negative 8.97. Yep. So let's check this now. Every single one of these is checkable. The check is two parts though. The first thing I want to do is check to see if sine of our answer theta gives us negative 0.44. So I'll do sine, and then I'll press second in the negative button. That'll give me the ants thing, which is just the last answer outputted by my calculator. So I do get negative 0.44. That's step one. The second step in my check is to make sure that my answer is bigger than negative 7 pi over 2 and smaller than negative 5 pi over 2. Or just that it's in between the two of them, right? So negative 7 pi over 2. Okay, well, we're bigger than negative 10.99. And then negative 5 pi over 2. And we're smaller than negative 8.5 or 7.85. So we're good, right? My negative 8.97 is in between these two numbers. And when I do sine of that, I get negative 0.44. So that's all I'm doing on my check, is just make sure that it satisfies the equation at the start and it's in between the two values in our range. Yes, sir.
And if like the answer you get 8.96, if that's like doesn't work, subtract.
No, it means that you've made a mistake. Yes. Likely the mistake would be either the pink circle or the blue circle, or it could be you put your terminal side in the wrong spot or something.
And when you go to
Okay. Nick, are you happy with what we did here? So this guy right here, this set of criteria would be something we'd want to have, right? Minimum, that's like a note card thing that I'd want to write down.
No, I remember what I was going to ask. When we get that number, that's radius, so you just put that over pi to make sure it fits into the equation or what?
No, we just do. So we're just going to check to make sure that this equation is satisfied. So I'm going to do sine of negative 8.97 and make sure I get negative 0.44. And then I'm going to make sure that negative 8.97 is in between those two numbers. That's it. I'm not going to do any unit conversion. I'm not doing any of that nonsense. I'm just going to make sure that, you know, negative 8.97 fits in between negative 7 pi over 2 and negative 5 pi over 2. I just type them into the two things into my calculator to get the decimal. And just make sure it's in between. You know what I mean? Like, let's do it the easy way, right? I'm about that life. Should we do another like this? Yeah? Does anyone have a preference on the number that we do? You want to do a tangent one, you said?
How about number 9?
Number 9. Great. Let's do that. How's your snack?
Good, thank you.
No problem. Shh. All right. First things first. Is this a calculator problem or a unit circle problem?
Calculator. Or unit circle.
This is a calculator problem. How do you know it's a calculator problem? Negative 3.25 isn't a coordinate on the unit circle, right? Or a, you know, division or product of two things on the unit circle, right? Okay. So let's start by drawing our picture. So now I'm going to look at this. Is my theta got to be negative or positive? Positive, because it's in between two positive numbers, right? If it's positive, which way are we going? Counterclockwise. So we're going that way. Everybody feel good?
Yes.
How much do I count by? Half a pi. So pi over 2, 2 pi over 2, or just 1 pi, 3 pi over 2, and I'm done counting because I've gotten to this guy, right? So I just stop when I get to the last one. So if I start at pi, or pi over 2, and I count this way, I'm covering quadrants 2 and 3. Everybody see? So far, so good? Okay. Next, I'm going to use the equation. So theta equals tan inverse of negative 3.25 is the same as just saying tan theta equals negative 3.25. Or that basically tangent is negative. So if we do all silly turtles crawl, again, the letters are telling us what trig function is positive in that quadrant. What quadrants then is tangent negative? 2 and 4 is correct. So S is sine is positive, but cosine and tangent would be negative. C is cosine is positive, but tangent and sine are negative. What's that, Gabby?
Why is it 2 and 4?
So the letter tells you what trig function is positive in that quadrant. So S tells us sine is positive there. So cosine and tangent are negative. We're concerned with where tangent is negative. So 2 is one of those places.
Oh.
In quadrant 3, T tells me tangent is positive, so it can't be negative there. Quadrant 4 says C tells us cosine is positive, so the other two, sine and tangent, must be negative, so that's one of them. A is for all, every one of them is positive in the first quadrant, so tangent can't be negative there.
So we're concerned with the A and the T, or the S and the C?
We're concerned with where tangent is negative. Yeah, Emily's got it. So where's the terminal side of theta have to be in? Quadrant 2. So when I know that my angle is going counterclockwise because it was positive. It always starts at the positive x-axis, and then I just kept going, right?
So what if you all or all
Is it then change it negative?
it is negative. Yeah. And tan is positive, right? And then all is positive. But sine and cosine is not. Because we need it to be negative. Okay. Yes.
Now let's draw our alpha. Let's draw our alpha. Alpha is always between the terminal side of theta. So that's this side. And the x-axis. It's always between the x-axis and the terminal side. Always x. Always x. So to calculate alpha, we're going to do tan inverse, because it's a tangent problem, absolute value, negative 3.25. Everybody feel good so far? Always absolute value. Every single time, positive, negative, whatever, absolute value. So my equation then, the first part is going to come from the label on the x-axis that makes up part of alpha. So pi. So we're doing next. So the next thing we need to do is figure out whether I should be adding or subtracting. To do that, we're going to look at which axis we cross right before the terminal side. So that's a y-axis this time. And because we are positive theta, right? Theta is positive in this case. We know that right from the beginning. So we should be using subtraction here. So that's my rule. And then it's always alpha at the end. Now, I'm not going to do the absolute value on my calculator. I'm just going to do the absolute value in my head because, I can make something positive. So I have 1.87.
So the 1.87 is the answer, not the equals pi minus 1.7?
Right. So if I do tan inverse of theta, or tan inverse of negative 3.25, or I'm sorry, positive 3.25, that's the alpha value. I don't care what alpha is. I care what theta is.
So theta is 1.7?
Correct. So alpha is just the value that I'm using to compute theta. It's what we call, its name for alpha is a reference angle. Doesn't really matter that you know that. I just call it alpha every time. Naya. So I typed into my calculator pi minus, and then tan inverse of the absolute value, negative 3.25. Yes. So theta is positive, and we cross the y, that means subtraction.
Oh, okay. So I thought, wait, so if it's positive, and it crosses the y-axis.
Subtract.
It's a subtraction. Yep, see, I just,
Okay. So to check, I'll just do tangent of my answer and make sure I get the negative 3.25. I do. And make sure that 1.87 is in between pi over 2 and 3 pi over 2. So it's bigger than pi over 2 and smaller than 3 pi over 2. So we got our correct answer. Here's the wonderful part of doing it this way, is it's always the same. Like every problem now essentially becomes the exact same. If you can draw the picture correctly and you remember the rule, every problem is the same. And I like the visual of it. I like that it connects these other ideas of like drawing these standard position angles, or if you're going positive, it's counterclockwise, and negative, it's clockwise. And we're using terms like initial side and terminal side. It's all bringing these ideas back together. So the visual I also find like pretty satisfying to look at. Like, oh yeah, okay, I can figure out where this thing has to be. You know, using these ideas of which trig functions are positive and which quadrants. What do you think? One more?
We take the quiz. What? Where to go?
No.
Yes, let's do it. I get it. Let's go.
Your calculator's about to die? There's one in the power strip over here. You're welcome to plug in.
I pick it up after study.
Sure. Yeah, that's fine. Sure, that's fine. Sure.
Instead of worrying about something, you choose to go to the bathroom.
In the bathroom.
Yeah, Nick. The unit circle? Yeah? Should we do that?
Can we do a question?
Sure.
Yeah.
Sure.
Yeah, you see it, long way messed up. That was still a great question.
Yeah, Gabby. I'm just like, I'm just trying to learn trigonometry here. You're just putting me down. Gabby, you make me feel bad about myself. I'm just trying to learn trigonometry.
Wow.
It's a big deal.
Wow.
It's very serious. I'm nervous at Gabby. Where'd you mark? Why do you have that?
I like both.
What'd you just say?
I'll pick
I said
let's try to focus. I picked what I think is the trickiest one from the unit circle problems. So first thing I'd want to do, let's look at this and identify how we know this is a unit circle problem as opposed to a calculator problem. What do I look at to see? Yeah, that's square root 3 over 3. Right? If I have a weird square root in there, it's probably a unit circle problem. Okay? So the next thing I want to do is, since this is tangent, on the unit circle, tangent means y over x. Is everybody okay there? Now, does anybody see a place on the unit circle where the x is 3 and the y is square root 3? No, right? Hey, will somebody grab the door for me real quick? Thanks, Ron. Now, tangent is weird because stuff can happen with the division, right? The other ones, sine, cosine, and even the reciprocals, cosecant and secant, are pretty easy. Tangent can be a little tricky because of this. So the way I would think about this is, let's think about 3 as the square root of 3 squared. Right? Because if I square a square root, they cancel each other out, and I'd be just left with 3. Everybody's good with how I can rewrite 3 as square root 3 over 3? Or I'm sorry, square root 3 squared. What's up? So I rewrote, if I do the square root of 3 squared, those guys would cancel out and I'm just left with 3, right? So I chose to rewrite 3 as square root of 3 squared because I am going to do this and do a little reducey. Oops, I didn't want purple. So far, so good. Now if I go look at my unit circle, do I see a place where y is 1 and the x is square root 3? Still don't see that, but I do see a place where y is 1/2 and x is square root 3 over 2, right? So if I just think about multiplying the top and bottom by 1/2, so I see that what I'm looking for is either that point or that point. Either where they're both positive, they're both negative. Roman.
Is that 6 or the square root 3 over 60? 1/2 over
Square root 3 over 2. This guy down here,
yes.
that's a 2. No problem. So if I go to my unit circle and I look these two guys up, grab that for a second, we'll drop it in. So that's my first spot. So I have pi over 6. And then my second spot is that one, which is 7 pi over 6.
Is it always opposite or no?
Nope. Yes. Yes.
Wait, what's the difference between those two problems? They're all the same. Yeah, they are. Oh, negative.
Yes, Anthony. We're not done with this, by the way.
Yeah.
Okay.
When you got 1 over square root 3, you multiplied it by 1/2 over 1/2.
Yes.
Why? What was the reason?
If I looked at the unit circle, there was no place where the point square root 3 comma 1 exists on the unit circle. But I did see I had 1/2 and square root 3 over 2, where if I put a denominator of 2 on both of those, then I do have that point. So that's what why I did that.
Is it always one to everyone else?
Is it always? No. For tangent problems, sometimes. Depends. Yes. Sure. Okay. So we have these two hypothetical answers, right? Are either of those answers between 3 pi and 4 pi? 1/6 pi and 7/6 pi? Neither one is in between, right? So what do I do? Let's check to see if there's an angle coterminal to them. So we'll add 2 pi, which is the 360 version of radians. Yup. So to add pi over 6 and 2 pi, what do I need to have? Common denominator. So let's think about 2 pi is 2 pi over 1. What would the common denominator be between pi over 6 and 2 pi over 1? So 6. So we'll multiply that by 6 over 6. So that gives me pi over 6 plus 12 pi over 6. To add those two fractions, once they have a common denominator, what do I get? 13 pi over 6. Now, if I look at that, that's like 2 1/6, right? Still not in between 3 pi and 4 pi, right? So that answer doesn't work. So let's check the next one. So I do the same thing. I'm not going to show the work for that, making the common denominator and all that, because we just did it above. 19 over 6 is 3 1/6. That is between 3 and 4. That's our answer. So this was the hardest one, I thought, on this sheet, because it's not obvious how to take the square root 3 over 3 and figure out like where that is on the unit circle. And even after you do that, you still have to go, the answers that you pull from the unit circle aren't the ones you need. You have to go and find the coterminal to that. Is that everybody okay there? Nick, you feel? This was the worst one, by the way. It's like as hard as it can get.
So we don't just use the angle that we get at the end.
Well, you have to check to see if it meets the criteria. If both answers don't, then you find the coterminal result and then check them again.
And to do that, we add
or subtract 2 pi, depending if your answer is too big or too small.
That's the check though, right?
No, that's to get the final answer. So the check would be just saying, is this result in between 3 pi and 4 pi? Yes. Yes, that is the only thing you can use to find coterminal angle. Well, unless it's in degrees, then it's 360, but it's the same angle, right? Is that okay? Always going to be 2 pi.
Okay, so then first we add it and then if it doesn't fit anymore.
Sound good? Do you want to see another? Okay. Okay, so today I want to finish chapter 4, so we're going to look at section 4.2. This is really nice, though, as section 4.2 is pretty easy. There's just like 2 pieces of vocab in here. Yes. So the two terms that you guys need that are new from section 4.2 is angle of elevation and then angle of depression. I'm not going to define what these things mean verbally because that's not how we're going to use them. What instead I'm going to do is give you like the visual definition of what they are. Is okay? So let's say we have two people, one person standing up high and the other person standing down low. And let's just say they're looking like straight ahead. So that's like their normal line of sight, right? If we take the person down low who's looking straight ahead, to look at the person up high, they have to lift their head a little bit. So that would be an angle of elevation. The person that's up high, to see the person down low, has to tilt their head down. So this angle here would be your angle of depression. So those two angles, as we've drawn them, what can we say about those two angles? They are congruent. Why are they congruent? They are alternate interior angles. You remember that term from geometry? Yeah. If I look at the angle of depression with this angle that I've starred, what's the relationship between those two angles? They're complementary. They are consecutive interior angles who add to give you 90 degrees. They're complementary. The most common mistake students make in these section 4.2 problems is drawing a picture and putting your angle of depression in the wrong spot. Okay? So the idea here, or your 4.2 homeworks that you're going to see, you're just going to get some story problems where the idea is you translate the story problem to a picture and then you use like SOHCAHTOA to find the desired result. So a couple of examples here. Here it says, Christy is looking at the Fisher Building in downtown Detroit. She is standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to measure 66 degrees. How tall is the Fisher Building? So here's Christy down here. There's the top of the Fisher Building. We're told that the angle of elevation is 66 degrees, so that's like there. We'll assume that any structure that's built on the ground is perpendicular to the ground unless stated otherwise. And we want to know how tall the Fisher Building is. So we'll call that side H. Oh, and we're 200 feet from the base. Everybody cool with how I've drawn the picture? The idea now is to just solve for H. So relative to that 66 degree angle, what is the 200-foot side? Opposite, adjacent, or hypotenuse? Adjacent. How about the H side? Opposite. So which trig function should I be using? Tangent. So I'll say tan 66 equals opposite over adjacent. So far, so good. To solve for H, what do I need to do? Multiply both sides by 200. And then into my calculator this goes. What do I need to do before I start typing this into my calculator, though? I need to change the mode from radian to degree. Very good. Will I have to do this during the test? Yes. Yeah, there will definitely be problems that require different modes on your calculator. So 49 or 449.2. Feels okay? Again, getting the picture is the hardest part. Let's do another. Jane has climbed a tree and is looking down at her friend Mary. Jane has climbed 17 feet into the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? Okay, we'll draw ourselves a picture. Here's Jane. Here's Mary. 17 feet in the air. Okay, so this would be 17. And where's that 49 degrees going to go? So you mean here? Okay, that's the mistake. Almost everybody makes this mistake. Remember, Jane's line of sight would be here, so our angle of depression should be there. Oops. That's the mistake. Almost everybody makes this mistake the first time doing this. I will promise you right now on your quiz or your test, I will try to trick you with this exact same setup. Yeah, awesome. So, good. So Massimo says then, well, this angle should be 41. Or you could say this angle down here is 49. Or you could draw like the blue triangle in like this. And, solve for that. Any one of those three ways of doing it are appropriate and correct. So whether you find the 41, whether you put the 49 down at M, or you draw the blue triangle, any of those is fine. What you can't do is put the 49 where we wanted to initially. So far, so good? So assuming we use the blue triangle, we got to pick one. What is 17 relative to the 49 degree angle in the blue triangle? Opposite, adjacent, or hypotenuse? Opposite. And the x is adjacent. So we need tangent. To solve this for x, what do we do? Multiply both sides by x to get it out of the denominator. And then we divide both sides by tan 49 to get the x by itself. And into my calculator we go. And we get 14.8. Does that feel okay there? Again, put a little reminder to yourself that I'm going to try to trick you with this setup for this problem. Okay? I promise you'll see that kind of setup again, where I'm going to try to trick you into putting the angle depression in the wrong spot. Be ready for it. All right. One more example, we can be finished here. All right. This says that Claude and Simone are riding bicycles in Paris. How romantic. At one point, they look up and measure the angle of elevation to the top of the Eiffel Tower to be 32 degrees. When they pedal 100 meters closer to the tower, the angle of elevation changes to 37.5 degrees. How tall do they estimate the Eiffel Tower to be? So that's kind of our picture, right? They measure the angle of elevation at 32 degrees. They go 100 meters closer. They do it again, and now it's 37.5 degrees. You want to know how tall the thing is. Everybody buy that? When I look at this, I see two right triangles. I see the big green triangle, and then I see the smaller blue triangle. Everybody see those two right triangles? So far, so good. If I look at those two right triangles, in either one of them, do I know an angle and a side length? The green one, we do not, because the 100 only applies to like this little part here. It doesn't apply to whatever this is. Everybody notice that we're missing, we don't have a side length and an angle for either right triangle. You guys can see that? However, this unknown piece is part of both triangles. So I'm going to call that x. If I redraw these two triangles then, I have that, right? What is the base for the 32-degree triangle? It's not 100. It's not x. It's not x. 100 plus x. That's excellent, Emily. Yes. Yeah. And the base for the 37.5 degree triangle is x. Everybody see that? Each triangle has two variables in it, right? Guess what we're going to do to solve this? We're going to write a system of two equations. So using the first triangle, I can say that tan 32 is equal to opposite over adjacent. Using the second triangle, I can do tan 37.5 equals opposite over adjacent. And that'll form my system of two equations. To solve a system of two equations, I can do algebraically, I do substitution or elimination, right? Does that sound like words you remember hearing? Let's use substitution here. So what I'm going to do is I'm going to get the x by itself in equation 2 and then substitute it in for the x in equation 1. Because what are we trying to be solving for here? Is h, right? So if I do that, I'd multiply both sides by x. And then divide both sides by tan 37.5. So I'm going to take that and plug it into there. Is everybody okay with the equation that I've written here? Who thinks it stinks looking at it? Yeah, it's pretty gross, right? All right, first order of business. When I look at this, there's several things I don't like that I'm going to work on trying to fix to make solving this easier. First thing that I see that I don't like is that I have a fraction inside of a bigger fraction. Right, I have this little fraction inside of the bigger fraction. You guys see that? That stinks. That's the first thing I'm going to fix. To fix that, I'm going to multiply the top and bottom by 37.5, or tan 37.5. So when I multiply h by tan 37.5, I just get h times tan 37.5. When I multiply 100 by tan 37.5, I just get 100 times tan 37.5. When I multiply h over tan 37.5 by tan 37.5, what do I get? Just h. Everybody's good there? That gets rid of the fraction inside of the fraction. The next step, the next thing I look at this and I don't like is that I have a fraction still, right? So let's multiply both sides by 100 tan 37.5 plus h. Now I don't have a fraction. Okay? But when I look at this, what do I still notice that's not great for us? Is I have h's in two different locations, right? I have two separate h's. To solve this, I need to get that h in two different locations to one location. So I'm going to try to get the h's both on the same side and then combine them together in some way. So to move that h over, I need to start by just distributing this thing through. So when I multiply tan 32 by 100 tan 37, I just get 100 tan 37 times tan 32. And then tan 32 times h is just h times tan 32. And now I'm going to subtract the h tan 32 from both sides. And you notice now my h's are both on the same side, right? How am I going to get those h's that are separate into one place, right? I have h's in two separate places. I want to get that h into one location. How do I do that? Believe it or not, you learned how to do this in middle school. So if I look at that guy and I look at that guy, what do you notice that's in a common factor between the two terms? Tan's not a factor, that's an operation, but h is in common. Everybody agree? Tangent's not a number, you can't factor that out, but h is like a number, so I can factor that out. So far, so good. So my last step then will be to divide both sides by tan 37.5 minus tan 32 to get h by itself. No, this was the third, example. Oh my gosh, yes. All right, now that I've got the h by itself, I can go to my calculator here. So I'll just go ahead and here I really want to make sure I use that horizontal fraction bar because this thing is like a nightmare to get in your calculator correctly without it. So I get 336.6. Now the algebra to do this was pretty rough, right? It's a lot of steps. When you guys talked about solving systems in Algebra 2, other than algebraic methods like substitution and elimination, what else did you talk about using? You would have talked about using graphing. That's also an acceptable method. Let's see how that compares to what we just did here. So, if I want to go the graphing route, let's use a different color. I want to get one variable by itself in both equations. If I look at the two equations, h seems like the easier variable to isolate. Do you agree with that? In the first equation, I'll just multiply both sides by 100 plus x. And in the second equation, I'll just multiply both sides by x. So here I'm using h as like my y coordinate. Everybody's okay with that idea? All right. So I'll go and I'll fire up my graphing calculator here. Let me move this out of the way. So I'll type in 100 plus x times tan 32 into y1, and x times tan 37.5 into y2. And then if I hit graph, I'm going to be looking for the intersection of these two curves. Mr. Kulik, what happened? This doesn't look right. I only got one curve. Where's the other one? I don't see any intersection. Did I do something wrong? No, nothing is wrong. You just picked a lousy window. If we're graphing over the standard window, x is going from -10 to 10, and y is going from -10 to 10. I don't know how tall the Eiffel Tower is. Anybody want to give me a decent guess? 2,000 feet? You're crazy. How about 500? Well, it's not a billion. Okay? So I know it's a positive number, right? The x is that distance, remaining distance to the base of the Eiffel Tower also. I don't know how far that is. I'm just going to do 500 also. Just going to guess. And now I'll hit graph. So here is one equation. Here's the second one. Oh, good. I can see them both. Are they going to cross? Yeah, they got them. So this place where they intersect is the spot I want. To have the calculator find that answer, I'm going to press second, trace. I'm going to pick, surprisingly, the intersect command. Now, when I use the intersect command, the calculator needs 3 inputs. It needs to know which two curves am I looking for the intersection on, and then a guess as to where about that intersection is. Here's the deal, though. We only have 2 curves. The 2 curves we drew are straight lines. How many times are they going to intersect? Just once. So the inputs don't really matter. So I'm just going to press enter 3 times real fast and not even think about it. So this tells me x is 438.6 and y is 336.6. Remember that y was representing my h. That's the number I want. So I'm just going to say h is 336.6. Yeah, guess what? You can do whichever one you want. So as far as work shown on your test, a picture, a system, and if you go graphing, give me a sketch of the picture from your calculator, and the answer is fine. If you prefer to do it algebraically, because you're like, yeah, I'm going to be doing something else. I'm going to do a hard class math class next year, and I know I got to be good at my algebra skills here. I'm going to challenge myself, make sure I can do that. That's totally fine. You can do it algebraically also. I've shown you both ways of doing it. It doesn't matter to me. That brings to the close this section 2. So your homework from this section is just the worksheet 3. I didn't get these printed for you, but they're in the OneNote. Probably easier to just do it in the OneNote because you have to draw pictures and stuff. But whatever you want to do is fine by me. Everybody feel okay with that? All right. We have not a lot of time left. So what does that mean for Friday? The homework quiz will be on Friday. If you still felt a little shaky on worksheets 1 and 2, make sure you've looked over those. Maybe rewatch the beginning of the lesson today again to kind of make sure you've got that down. What else happens on Friday? It's the test review day. So your half sheet would be due on Friday if you're somebody that wants to get a jump on working on that beforehand. You can start on it now. Just giving you the heads up. If the test review is on Friday, what day is the test going to be? Tuesday. Tuesday. Everybody good?
That's just how it goes.
Okay.